Example 6. Find all solutions to sine of x equals -8/9 on the interval 0 degrees less than or equal to x less than 360 degrees. We are looking for the angles with a y value of -8/9 on the unit circle. Immediately, we can see the solutions will be in the third and fourth quadrants. First, we will turn our calculator to degree mode. Using the inverse, we can find one solution, x equals sine inverse of -8/9 is approximately -62.734 degrees. While this angle satisfies the equation, it does not lie in the domain we are looking for. To find the angles in the desired domain, we start looking for additional solutions. First, an angle coterminal with -62.734 degrees will have the same sign. By adding a full rotation, we can find an angle in the desired domain with the same sign. X equals -62.734 degrees plus 360 degrees equals 297.266 degrees. There is a second angle in the desired domain that lies in the third quadrant. Notice that 62.734 degrees is the reference angle for all solutions. So the second solution would be 62.734 degrees past 180 degrees. X equals 62.734 degrees plus 180 degrees equals 242.734 degrees. The two solutions on 0 degrees less than or equal to x less than 360 degrees are x equals 297.266 degrees and x equals 242.734 degrees. Example 7. Find all solutions to tangent of x equals 3 on 0 less than or equal to x less than 2 pi. Using the inverse tangent function, we can find one solution, x equals tangent inverse of 3, it's approximately 1.249. Unlike the sine and cosine, the tangent function only attains any output value once per cycle, so there is no second solution in any one cycle. By adding pi, a full period of tangent function, we can find a second angle with the same tangent value. Notice this gives another angle where the line has the same slope. If additional solutions were desired, we can continue to add multiples of pi, so all solutions would take on the form x equals 1.249 plus k pi. However, we are only interested in 0 less than or equal to x less than 2 pi. X equals 1.249 plus pi equals 4.391. The two solutions on 0 less than or equal to x less than 2 pi are x equals 1.249 and x equals 4.391. Example 8. Solve 3 cosine of t plus 4 equals 2 for all solutions on one cycle. 0 less than or equal to t less than 2 pi. 3 cosine of t plus 4 equals 2, isolating the cosine. 3 cosine of t equals -2. Cosine of t equals -2/3. Using the inverse, we could find one solution. T equals cosine inverse of -2/3, approximately 2.301. We are looking for two angles where the x-coordinate on a unit circle is -2/3. A second angle with the same cosine would be located in the third quadrant. Notice that the location of this angle could be represented as t equals -2.301. To represent this as a positive angle, we could find a coterminal angle by adding a full circle. T equals -2.301 plus 2 pi equals 3.982. The equation has two solutions between 0 and 2 pi at t equals 2.301 and t equals 3.982. Example 9. Solve cosine of 3t equals 0.2 for all solutions on two circles. 0 less than or equal to t less than 4 pi divided by 3. As before, with the horizontal compression, it can be helpful to make a substitution, u equals 3t. Making this substitution simplifies the equation to a form we have already solved. Cosine of u equals 0.2. U equals cosine inverse of 0.2, approximately 1.369. A second solution on one cycle would be located in the fourth quadrant with the same reference angle. U equals 2 pi minus 1.369 equals 4.914. In this case, we need all solutions on two cycles, so we need to find the solutions on the second cycle. We can do this by adding a full rotation to the previous two solutions. U equals 1.369 plus 2 pi equals 7.653. U equals 4.914 plus 2 pi equals 11.197. Undoing the substitution, we obtain our four solutions. 3t equals 1.369, so t equals 0.456. 3t equals 4.914, so t equals 1.638. 3t equals 7.653, so t equals 2.551. 3t equals 11.197, so t equals 3.732. Example 10. Solve 3 sine of pi t equals -2 for all solutions. 3 sine of pi t equals -2, isolating the sign. Sine of pi t equals -2/3. We make the substitution. U equals pi t. Sine of u equals -2/3. Using the inverse, we find one solution. U equals sine inverse of -2/3, approximately -0.730. This angle is in the fourth quadrant. A second angle with the same sign would be in the third quadrant with 0.730 as a reference angle. U equals pi plus 0.730 equals 3.871. We can write all solutions to the equation. Sine of u equals -2/3 as u equals -0.730 plus 2 pi k, or u equals 3.871 plus 2 pi k, where k is an integer. Undoing our substitution, we can replace u in our solutions with u equals pi t and solve for t. Pi t equals -0.730 plus 2 pi k, or pi t equals 3.871 plus 2 pi k. Divide by pi. T equals -0.232 plus 2k, or t equals 1.232 plus 2k. Solving trig equations. 1. Isolate the trig function on one side of the equation. 2. Make a substitution for the inside of the sine, cosine, or tangent, or other trig function. 3. Use inverse trig functions to find one solution. 4. Use symmetries to find a second solution on one cycle when a second exists. 5. Find additional solutions if needed by adding full periods. 6. Undo the substitution. We can now return to the question we began the section with. Example 11. The height of a rider on the London Eye Ferris wheel can be determined by the equation h of t equals -65 cosine of pi divided by 15t plus 70. How long is the rider more than 100 meters above ground? To find how long the rider is above 100 meters, we first find the times at which the rider is at a height of 100 meters by solving h of t equals 100. 100 equals -65 cosine of pi divided by 15t plus 75. U equals cosine inverse of 30 divided by -65, approximately 2.051. This angle is in the second quadrant. A second angle with the same cosine would be symmetric in the third quadrant. This angle could be represented as u equals -2.051, but we need a coterminal positive angle, so we add 2 pi. U equals 2 pi minus 2.051, approximately 4.230. Now we can undo the substitution to solve for t. Pi divided by 15t equals 2.051, so t equals 9.793 minutes after the start of the ride. Pi divided by 15t equals 4.230, so t equals 20.197 minutes after the start of the ride. A rider will be at 100 meters after 9.793 minutes and again after 20.197 minutes. From the behavior of the height graph, we know the rider will be above 100 meters between these times. A rider will be above 100 meters for 20.197 minus 9.793 equals 10.404 minutes of the ride.